this logarithmic decrement is it is defined as the ratio, defined as the logarithm, that is logarithm of two successive deflection of the this is amplitude of deflection of the galvanometer. Yeah. So how to define the concept by using the case? As we know, that is, equation is d2 theta by dt square plus 2b d theta by dt plus omega square theta is equal to 0. This one is the equation of the galvanometer, and solution, as we have theta of t is equal to this omega 0 by 2p e raised to the power minus b plus pt minus omega 0 by 2p e raised to the power minus b minus pt. This one is the equation. Or इस equation के what we find, we have three solutions. Equation के three solutions हैं. That is case one, that is theta is, case one is damped. Case two is critically damped. And case three, what is the problem? There is some problem in sharing it. So what I have, if you go, this bar is down. Save. Successfully save. Back to library. There is some problem and I will try to solve it. Now it is okay. Share this screen. Yes. So what we feel, critically damped. And third case is oscillatory. Third case is oscillatory. In the oscillatory case, we have theta t is equal to omega 0 by omega dash e raised to the power minus beta into sine omega dash t. This one the solution of oscillatory equation. And we have to proceed from this way. So the graph is something like this. Graph is something like this. So this is your 0, here it is theta of t, and this is your t, and this point is theta 1, this point is theta 2, this point is theta 3, this point is theta 4, this point is theta 5. So this is 1, this is 2, this is 3, this is 4, this is 5, and similarly. And this point, this time is t dash. This time is t dash. This time is t dash. So this point is t dash by 2. This point is t dash by 2. And this point is t dash by 4. This point is t dash by 4. So what we have to find out, maximum deflection, expression for maximum deflection. For maximum deflection, differentiate theta of t with respect to t. That is d theta by dt is equal to omega 0 by omega dash e raised to the power minus bt of minus b into sine of omega dash t plus omega 0 by omega dash e raised to the power bt, and then cos omega dash t into omega dash. This one is. So the common portion is omega 0 by omega dash e raised to the power minus bt, and inside bracket is minus b sine omega dash t plus omega dash cos omega dash t. Now for maximum we have to put this equal to 0. So this 0 is equal to, this part is not equal to 0. So remaining this factor must be equal to 0. That is minus b sine omega dash t plus omega dash cos omega dash t is equal to 0. That is b sine omega dash t is equal to omega dash cos omega dash t. So sine omega dash t divided by cos omega dash t, this ratio is nothing but tan omega dash t is equal to omega dash by b. Omega dash by b. So if we take this one is a right angle triangle, so this angle This angle is omega dash t, omega dash t. So this is omega dash by b, omega dash by b. And here it is omega 0. This is omega 0. So in this way, what we find, this one is the factor. This one is the factor which is important for us. And this is sine omega dash t is equal to omega dash t is equal to omega dash t for small deflection. For small deflection. And these conditions are the basis of our, logarithmic decrement. And what we find, let us save this page and comes to the new page. This part is as we have substituting this value theta of t is equal to omega 0 by omega dash e raised to the power bt into sine omega dash t, sine omega dash t. And this sine omega dash t is how much? This is omega 0 by omega dash e raised to the power minus bt. And this sine omega dash is omega dash by omega 0. Omega dash by omega 0. Or omega t, you can substitute. So this will be what? E raised to the power minus bt. E raised to the power minus bt. And one thing is important for case, what will the value of this for the first throw, that is we have to consider the case as first maximum throw, that is theta 1. First maximum throw is theta 1. So this theta 1 is equal to, from where we consider this is theta t. So theta 1 is equal to omega 0 by omega dash e raised to the power minus bt into 1. Why it is 1? Because sine omega dash t is 1. Sine omega dash t is 1 when the time is correlated as omega dash t is equal to pi by, this is pi by 2. This is pi by 2. So what we'll find? We find this t is equal to pi by 2 into 1 by omega dash. That is pi by 2 into omega dash means this is 2 pi by t dash. 2 pi by t dash. So this pi cancel. So it is t dash by 4. T is t dash by 4. And it is very clear as from the graph also, that is if this one is the theta and here it is, this is t dash by 2 and this one is the value of theta 1 and at this will be t dash by 4. That is t dash by 4. So this is your time and here it is the theta t. So theta 1 is max. So theta 1 is omega 0 by omega dash e raised to the power minus b, e raised to the power minus b, and the value of t is t dash by 4. The value of t dash is t dash by 4. So what is the value of theta 2? Now from the graph, this theta 2 is omega 0 by omega dash e raised to the power minus b. And this value of time is what? 3t by 4. This value of time is 3. So this is 3t dash by 4. This is theta 2. This is theta 2. This is theta 3. And what is theta 3? This one is the theta 3. So what is this is t dash. So this value time is equal to t dash plus t dash by 4. So this is 5t dash by 4. 5t dash by 4. So theta 3 is omega 0 by omega dash e raised to the power minus b, 5t dash by 4. 5t dash by 4. Similarly, what we find? We find that theta 1 is here, and this theta 2 is 3, and theta 3 is 5. So whatever theta n, this theta n is omega 0 by omega dash e raised to the power minus b, 5. 5 can be 2n minus 1 upon 4 into t dash, 2n minus 4. So if n is 3, so 3 into 2, 6 minus 1 is 5. N is 2, so 2 into 2, 4 minus 1 is 3. And here n is 1, 2 into 1 is 2 minus 1 is 1. So this one is the value of various amplitudes in the oscillation of this case. Now we have to say the word successive for the successive amplitude. For the successive amplitude, that is theta 1 and theta 2. Successive are theta 2 and theta 3. So ratio of successive amplitude. The ratio, what is the ratio? Theta 1 by theta 2. Theta 1 by theta 2. So what is theta 1 by theta 2? We see theta 1 is omega 0 by omega dash e raised to the power minus bt dash by 4. And it is divided by this is omega 0 by omega dash and e raised to the power, this is the minus, so minus is plus b 3t dash by 4. So this omega j cancel with omega dash is cancelled with this omega. So here it is e raised to the power, if we take b common, so 3t dash by 4 minus t dash by 4. Minus t dash by 4. So this is equal to EB, and here it is 2t dash by 4. 2t dash by 4. And this is e raised to the power b t dash by 2. B t dash by 2. And R we can consider here theta 1 by theta 2 is equal to e raised to the power b t dash by 2, and this can be also written as e raised to the power lambda, say, where lambda is constant. It is the constant, and this constant is how much? Lambda is equal to bt dash by 2. Bt dash by 2. This is the constant. Now, when we take log of both the side, taking log of both the sides, we have this is log of theta 1 by theta 2 is equal to log of e raised to the power b t dash by 2 is equal to log of e raised to the power lambda. So what we find, this is the lambda. So lambda is equal to log of theta 1 by theta 2. Theta 1 by theta 2, and this is also equal to b t dash by 2. So this is known as logarithmic decrement. This is known as logarithmic decrement. For practical purpose, this is theoretical. For the practical purpose, we have what we have. Theta 1 by theta 2 is equal to theta 2 by theta 3 is equal to theta 3 by theta 4 is equal to theta n minus 1 upon theta n, and again this one is e raised to the power lambda. E raised to the power lambda, or theta 1 by theta 2 into theta 2 by theta 3 into theta 3 by theta 4 into this is theta n minus 2 upon theta n minus 1 into theta n minus 1 upon theta n is equal to. Now, what will be the value in this case? So this is 1, 2, 3, and up to this is the n minus 1. This is the n minus 1. So this will give, here it is theta 2 cancel theta 1, theta 3 cancel theta 4 will cancel similarly, and this cancel this way. So e raised to the power n lambda, e raised to the power n minus 1 lambda. This is n minus 1 lambda.
सर थीटा 4 किससे कैंसिल हुआ?
थीटा
4.
हाँ यस क्या
सर थीटा 4 कैंसिल कैसे हुआ?
कैंसिल होगा, उसके बाद ये डॉटेड लाइन दिया है ना, तो यहाँ पे कुछ होगा डॉटेड लाइन में. डॉटेड लाइन में क्या होगा? थीटा 4 अपॉन थीटा 5.
यस सर.
है ना? तो ये थीटा 1 अपॉन थीटा n इज इक्वल टू e रेज टू द पावर माइनस n माइनस 1 इंटू लेमडा, और इसको लॉग ले लें, दोनों साइड में लॉग ले, तो लॉग ऑफ थीटा 1 अपॉन थीटा n इज इक्वल टू n माइनस 1 इंटू लेमडा. ठीक है, n माइनस 1 इंटू लेमडा. सो व्हाट, अब लेमडा के मान क्या हो जाएगा? दिस लेमडा इज इक्वल टू 1 by n minus 1 log theta 1 upon theta n. ठीक है, ये हो जाता है प्रैक्टिकल में. अब प्रैक्टिकल पर्पस में क्या करते हैं कि थीटा 1 एंड थीटा 11 फॉर बुक्स में प्रैक्टिकल्स के बुक्स में लिखा है n is equal to 11. That is, we have to take theta 1 and theta 11. थीटा 1 और थीटा 11 लिखेंगे तो क्या हो जाएगा? दिस लेमडा इज इक्वल टू 1 अपॉन 11 माइनस 1 log theta 1 by theta 11. Theta 1 by theta 11. So this one is what? 1 by 10. 1 by 10 ln theta 1 upon theta 11. Theta 1 upon theta 11. So this theta 1 by theta 11, it is the log base. It is the log base. This log base can be this θ1 for practical purpose this lambda is 1/10 ln θ1 by θ11, है ना? This is natural log. This can be converted into log base 10. Log base 10 के लिए क्या होगा? 2.303 upon 10 upon 10. And this log base 10 θ1 upon θ11. θ1 upon θ11. And this one is lambda. This one is lambda. तो हम जो प्रैक्टिकल पर्पस के लिए ये फॉर्मूले का यूज करते हैं जो प्रैक्टिकल के बुक में दिया है, बुक है ना, इन प्रैक्टिकल पर्पस. ठीक है, प्रैक्टिकल पर्पस के लिए ये चीज आपको यहाँ पर दिया रहता है. अब इसकी मीनिंग क्या हो गई? फिजिकल सिग्निफिकेंस. फिजिकल सिग्निफिकेंस मैथमेटिक्स तो हो गया, लेकिन इसकी फिजिकल सिग्निफिकेंस को भी समझना बहुत जरूरी है, क्योंकि अक्सर पूछा जाता है कि व्हाट डू यू मीन बाय फिजिकल सिग्निफिकेंस ऑफ लॉगरिथमिक डिक्रीमेंट. तो देखिए, हम करते हैं कि जो हमारे पास एक्सप्रेशन है, किसका एक्सप्रेशन? वी हैव दिस θ1. θ1 is omega 0 by omega dash e raised to the power minus lambda by 2. e raised to the power minus lambda by 2. ये माइनस लेमडा बाई 2 कहां से आ गया? क्योंकि e raised to the power minus bt है ना, bt by 2, और लेमडा में क्या होगा? bt dash by 4. तो 4 के जगह पे 2, तो दिस वन इज e lambda by 2. So this can be also expressed as θ0 e raised to the power minus lambda by 2, है ना? Or this can be expressed as θ0 is equal to θ1 into e raised to the power lambda by 2. ठीक है, θ0 is equal to θ1 into e raised to the power lambda by 2. And what is e raised to the power 1 lambda by 2? This is 1 plus lambda by 2 plus हायर ऑर्डर टर्म्स, जिस टर्म्स को हमें अभी जरूरत नहीं है. तो हम इसको लिख देंगे θ1 प्लस लेमडा बाई 2. ये जानना बहुत जरूरी है. θ0 इज, तो जो फर्स्ट डिफ्लेक्शन,
कुछ लोग वेट लिस्ट में है, वो लोग क्लास से छूट गए थे,
जाने दीजिए. ये दिस इज योर t and this one is the theta of t. This is theta of t. Now we have to explain this expression. What do you mean by this expression? देखिए, हम जो प्लॉट करते हैं वो इस तरह के प्लॉट आता है. This is the plot, and this plot gives, this one is the value θ1 आ रहा है. तो जो θ0 होगा वो क्या होगा? दिस θ0 इज θ1 प्लस θ1 इंटू लेमडा बाई 2, है ना? θ1 प्लस लेमडा बाई 2, मतलब जो ये वैल्यू आ रही है θ1 की, ये जो वैल्यू आ रही है इसके करस्पॉन्डिंग, इतना तो होगा ही θ0, और इससे प्लस ये एडिशनल होगा. यदि ये एडिशनल होगा तो उसको यदि हम दिखाना चाहें तो हम दिखा सकते हैं इस तरह से. दिस वैल्यू इज समथिंग, दिस इज द θ0. तो θ0 इज इक्वल टू θ1 प्लस लेमडा बाई 2. तो इसमें इतना चीज और ज्यादा होगा. मीन्स क्या हो रहा है कि θ0 इज ग्रेटर देन θ1. तो जो फर्स्ट डिफ्लेक्शन आप मेजर करते हैं, माइंड इट, जो फर्स्ट डिफ्लेक्शन मेजर करते हैं उससे θ0 एक्चुअली बड़ा होगा. θ0 एक्चुअली बड़ा होगा. तो जो मेजर कर रहे हैं उसमें ये पोर्शन हम मेजर नहीं कर पाते. कारण क्या है, व्हाट इज द रीजन बिहाइंड दिस? इसलिए कि ये जो होता है t/4, यहाँ पे क्या होगा, दिस इज t डैश, दिस इज t डैश बाई 2 एंड दिस इज t डैश बाई 4। तो t डैश बाई 4 में गैलोमीटर में डैम्पिंग क्रिएट हो जाता है ना? तो दिस इज करेक्शन फैक्टर इन डैम्पिंग। सो the actual deflection is more than the observed deflection, है ना? And it is because of damping during t dash by 4. This is t dash by 4. तो ये जो थीटा 0 है, ये हमारा इंपॉर्टेंट एक्सप्रेशन है, और एक्चुअल डिफ्लेक्शन को मेजर करना है। और अलग से जब एक्सपेरिमेंट आप देखते हैं उसमें ये थीटा 0 की जरूरत पड़ेगी। तो थीटा 0 की जगह पे क्या लिख देंगे, थीटा 1 + 1 by lambda by 2, and where lambda is logarithmic decrement, है ना? तो जहां भी एक्चुअल कैलकुलेशन करना होता है वहां पर हम थीटा 0 के मेजर करते हैं, और थीटा 0 के जगह पे लिखते हैं थीटा 1 + 1 plus lambda by 2, and lambda by 2 is the logarithmic decrement which is expressed over there. तो थीटा 0 कैलकुलेट करना है, थीटा 0 कैलकुलेट करना है तो क्या करेंगे, पहले हम थीटा 1 लेंगे और फिर थीटा 1 एंड थीटा 11 निकाल करके, और तब ये कोई जरूरी नहीं है, कभी कभी क्या होता है कि बहुत ज्यादा डैम्पिंग होता है तो 11 डिफ्लेक्शन आपको नहीं मिलेगा, है ना? जैसे मान लीजिए ये स्केल है, अभी हम उसको डिटेल में डिस्कस करेंगे। ये स्केल है, ये सेंट्रल पॉइंट है, और पहला डिफ्लेक्शन यहाँ आया और दूसरा फिर यहाँ आया, थीटा 1 यहाँ है, थीटा 2 यहाँ है, फिर थीटा 3 यहाँ होगा, थीटा 4 यहाँ होगा, थीटा 5 इधर होगा। तो ये धीरे धीरे क्या है, डिफ्लेक्शन कम होता जा रहा है, इधर से भी डिफ्लेक्शन कम होता जा रहा है। तो हम हमेशा कोशिश करेंगे 1 3 5 मतलब ऑड वैल्यू लेने के लिए, वी ऑलवेज ट्राई टू टेक द ऑड वैल्यू ऑफ द डिफ्लेक्शन, और ऑड वैल्यू लेकर के कर सकते हैं। जैसे थीटा 1 थीटा 9 भी कर सकते हैं, तो 9 - 1 is 8, तो 10 के जगह पे 8 हो जाएगा। तो दिस इज ऑल अबाउट द लॉगरिथमिक डिक्रीमेंट, कैसे डिफाइन करेंगे और उसका फिजिकल सिग्निफिकेंस क्या है, ये चीज बहुत इंपॉर्टेंट है। और ये आपका इंपॉर्टेंस जो है, आपका जो फर्स्ट ईयर के या फर्स्ट सेमेस्टर के जो एक्सपेरिमेंट है चार्ज सेंसिटिविटी, उसके अलावा जब आप सेकेंड, थर्ड एंड फोर्थ में जाएंगे तो वहां पर आपको मिलेगा अर्थ इंडक्टर और सर्च कॉइल, दो वहां पे एक्सपेरिमेंट है दैट इज बेस्ड ऑन बैलिस्टिक गैलोमीटर, दैट इज ऑसिलेशन। सो दिस वन इज अ वेरी इंपॉर्टेंट। और इस तरह से हम लोगों के पास केवल 1 मिनट बचा है, तो हम इसको फिर एंड करेंगे एंड देन वी विल स्टार्ट द न्यू सेशन। तो उसके पास आप ज्वाइन करिएगा।